Assalamu alaikum. My name is Dr. Usman Paracha, and today we would be having our lecture number 5 of the subject Applied Quantitative Analysis and Practices. Previously, going to the recap of the lecture which we did before, we had a brief about the graphical errors which normally happen while you are presenting your analytical data to the audience. The common graphical errors include the scale of the graphs which is presented, and normally the scale variation depends upon the way how you present to them. Then after graphical errors, we discussed about the modeling of how real management phenomena is done, and how the intangible factors are converted into tangible concepts, and then how they are visualized, how they are put together, and then how do these concepts impact the main dependent factor in any organization. Then how do we measure these concepts? And in that case, we just discussed about the way they are measured, how we use survey-based approach, how we use questionnaires in order to measure such concepts, and questionnaire related to any specific construct can include many dimensions or few dimensions depending upon the depth of the concept which is being used to measure in that specific organization. So once we have gone through the questionnaire approach and we have determined the way to measure such concepts, then we use a certain scale in which the respondent has to answer. Once he takes that specific scale, then we can determine the intensity of that specific factor which is being measured specifically in that organization. So once we have got the feedback from these employees or these respondents, then the part comes that how to analyze the data. So we take the aid of a software which is SPSS. We had the introduction of this software, and after when we have had this introduction, we had a look at how we have to introduce the variables in SPSS and how we have to define them, and then how coding of these 5-point scales in questionnaire has to be done in SPSS, how each variable was defined from that 5-point scale perspective. Once the coding of this 5-point scale is done, then how we have to enter the data in SPSS. So just going through the previous slide, this was just a brief outlook of the model which we did previously, and we just imagined and hypothesized that a certain I would say human resource management practices have an impact on a certain attitude and behavior of an employee. Here in this case it is employee commitment or organizational commitment of an employee. Now the human resource management practices being considered in this case and in this organization were employee participation, training, performance appraisal, career planning, job definition, and compensation. There are many other human resource practices which exist, but here in this case we are just taking a few for our convenience, and then we did measure these practices through certain questionnaires, and in this case we can just have a recap of that questionnaire as well. So going through the questionnaire, yes, we can see here that in the questionnaire, for example, training aspect was being measured through 6 questions, and each question was being scaled on a 5-point scale. It's ranging from 1 to 5. 1 means strongly disagree, 2 disagree, 3 neutral, 4 agree, and 5 strongly agree. So we asked the relevant questions from the employees which represent the certain dimensions of the training aspect, and once we have determined the dimensions, those relative questions were put forward to the employee, and the employee had to answer these certain aspects. Now once he has answered all these questions from 1 to 5, then we had to enter these things in SPSS. So going through that, we made a testing file in SPSS, and first, as you can see in the bottom left corner, we went to the variable view of SPSS, and then we just started entering the variable name, like TR1 here represents the first item of the questionnaire, and in that case we labeled it as training variable 1, and we entered the values which can be seen here if we click on it and click on the button here. So all the value labels for that variable were entered and defined here, and then again we had to define that what kind of variable is it under the measure column, which is at the end. So we had to define whether it was a scale variable or ordinal variable or a nominal variable. So it was a nominal variable here in this case. So again we entered the 3 questions of training, and then we entered the gender here as well, which was comprising of male and female option, and we categorized this variable as nominal variable in this case. So coming to the data view, we just showed the variables in the first 3 columns, and again the 4th as well. Now we entered the relative values which the respondent has entered in the questionnaire, and let's say in this case the gender of the employee was male. So here let's say we enter 0 for male here. So 0 represents male and 1 represents female. So this was the sample data which was entered here in SPSS, and then now we will go ahead with how to enter the complete data, and then what information can we get from this data, which we will enter here in SPSS. So now after we have entered these 4 variables, we will go to the 5th one. You might have noticed in the questionnaire we discussed that there was a field in demographics area in which we were asking for the experience of the respondent. So let's enter this new field in variable view, and in the 5th variable we can see that here experience, we will just write it as EXP for a shortened name. Mind you that you would have to be very careful while designating a name of the variable, because it should be as short as possible. If you want to give more details about the variable, you can do it in the label column, which is in the 5th column here. So I just write experience as exp and assign the variable. We take it as numeric because we have to enter the numerical values. Again, in experience we are only counting years and not months, so there won't be any decimals involved here. So we reduce the decimal to 0, and then we click on the label and we just write down the complete name, which is experience here. So we won't be assigning any value to this variable, so it will remain as none, because in experience the respondent has to write the number of years he has worked in that organization. So it's a numerical value with no predetermined scales. However, we have to decide now that what year this variable will be given. So here we just click on the year and we click on the downward arrow, and we have got a drop down menu here, in which again we have to choose between the scale, ordinal and nominal. Now here, as there is only a definite number which a respondent has to enter in the questionnaire, so this would be either an interval variable or a ratio. So both of these variables are covered in the scale year, which is identified here in SPSS. So we assign scale to this year here. So now, as we have assigned the demographic variables here, then we would now go to the data view, and in data view you can just click on the experience column and you can write any number of experience which the respondent might have entered in the questionnaire. So let's say he has entered 26 years of experience. We type 26 here. So once we have completed this, we can go to the second row and start entering the values for the second respondent. So once we have entered all the values for all the respondents, then we can have a look at the analysis part about how to go through the analysis. We would just have a sample file in which all these values have been entered. So going to the file, so this is a sample file in which all the values have been entered for that questionnaire which we had discussed before. And in that questionnaire you must have noticed that there were 6 questions regarding training. So here we have got 6 variables for training, and we can see that in variable view aspect as well. Here you can easily see that in row number 5 the training variable 1 tr1 is written, which is representing the first question of training. Then likewise all the other questions of training are followed, and all of them have been measured through ordinal scale. Likewise, the performance appraisal variable is written here as PRA1, which represents the first question of performance appraisal, and likewise all the relevant questions are entered below. So likewise career planning questions have been enlisted from 1 to 7 here, designated as CRP1, CRP2 and so on. Then here, let's say in 25th row, EP1 represents employee participation, which you can easily see under the label column, in which the description of that variable has been clearly entered, and that's why we use label column for this purpose. However, the name of that variable will be taken as the shortest one possible. Here it is EP1. Similarly, JD1 here represents the job definition. The three questions have been written as under JD1, JD2 and JD3. Then compensation basically is representing the one aspect of compensation variable. The compensation 1 is first question of compensation. Likewise, compensation 2 and 3 are enlisted. Then here under this we are entering the variable related to organizational commitment. Here it is termed as effective commitment, but this is one dimension of organizational commitment which we would be taking as the primary dimension. So we would be taking organizational commitment as AC1, which represents the first question of organizational commitment, and likewise all the other 7 questions are enlisted below this AC1. And again, as this variable has been measured on ordinal scale, so we have termed it as ordinal scale here. So all these values have been entered, and here the demographics again are represented in the first 4 first 4 rows, and which represent the school code, respondent type, gender type and experience. Here the school code represents the relative school which is being considered, as one school can comprise of many respondents, so we have to differentiate them by school code here. Going to data view, here you can see the school code which is being written here, and respondent RES 1 means here you can again look at the variable view in order to know what type of respondent is being entered, and respondent type values, if we click on them, and then there are 2 types of respondents here. One represents the teaching staff, the 2 here represents the principal. So again, going back to the data view, we can see that the various respondents are entered here and represented by the coding which we have already done here before. So once we have done all the coding and we have entered the data for all the respondents here, which you can see it comprises of round about in this case, this is the data of 720 respondents which have been collected. The data from there is collected from different schools. So now, as we have discussed in the previous lecture, that it is important how we represent the data graphically. So let's say if you want to have this data represented graphically, so we click on Analyze in the menu bar and we click on Descriptive Statistics option, and under this you can see that there is an option called Explore. So we click on that. Now a dialog box appears, and in which on the left hand side we are given a list of variables which we have just defined, and the way these variables are enlisted can also be changed. If we just put the arrow on these variables and right click on them, then a menu appears, and in which currently we are seeing these variables as display variable labels. So it is displaying the variables label wise. If you want to get this display name wise, so you can just click on display variable names, and once you click on it, then the display on the left hand side changes and the variables are listed here from the name perspective, which are again the shortened version of these variables. Again, if we right click on it, then you can see that the menu appears again. We can click back on display variable labels, and again you can enlist these variables from label perspective. So right clicking on it again, we have got other information here which can be selected. We can sort them by file order, you can sort them alphabetically, or sort them by measurement level, which again is from the perspective of scale, nominal and ordinal. So it can sort them from that perspective. You can get the variable information here as well. By clicking on it, you can see that the variable information is now displayed with the name, its label, and the value labels which have been defined. If you just click on the downward arrow, you can see the values which we had assigned to this variable. So you can get the relevant information of the variable here in this dialog box as well. So by clicking on this cross, we can just minimize this thing, and now we have to select the variable which we want to explore through graphical means, through descriptive means. So we just, let's say, want to know about the first question which the respondents have answered. So by selecting this first variable, and we can just click on the arrow which is near the dependent list. By clicking on it, you can see that this variable has been selected, and now we have to mention what kind of information we want to have about this variable. So we can click on statistics button, and here you can see the descriptive part is already highlighted, and let's say we want to know about the outliers in this variable as well, and we can have the information about the percentiles as well, which is not required normally here. So we just click on continue. Then again, clicking on the button below the statistics is the plots. So clicking on it, we are given option about various plots or graphs we can have. So for now, we would just want to have a stem and leaf display, which is already ticked under descriptive part, and we want to have the histogram of this data as well. So if we click on this again, and we click on the continue button, then clicking on the options button here, we can see we are given options regarding missing values, that if there are any values which are entered here and if any of them is missing, then what should SPSS do with such values? Either it should exclude the cases list-wise, or exclude the cases pairwise, or report values. So we have clicked on exclude cases list-wise. For example, among all these variables in a single row, if any one value is missing in any variable, then SPSS will exclude that whole row. So this is the thing which is being preferred, but normally this is preferred that while performing a survey, we already exclude those questionnaires in which all the values, or if any of the value in that questionnaire is missing. So we exclude that factor already. So by default, we have entered only those values, only those questions which have got all the values from the respondents. So in this case, as a precaution, we are ticking on exclude cases list-wise, so that we can come to know that while entering the data, if any variable value has not been entered by mistake, then it should report that anomaly to us so that we can rectify that mistake. So we click on continue here and we click on OK. So here another window opens which displays the values. Now let's have a look at the left hand side, which is giving us the heading of each kind of descriptive result which is being displayed. For now we are interested in only the histogram, which you can see here on the left side. I have clicked on it. So once I've clicked on it, now the SPSS is displaying the histogram of these variables, of this one variable, and you can see the various frequencies here, and you can see that one value, how many what is the frequency of more than 100 respondents have basically clicked on one example, on one option. Then more than around about 200 respondents have opted for second scale for this question. Likewise, more than 150 respondents have opted for the third option in that question, and vice versa. You can have a look at this thing. So if I click on the stem and leaf plot, which is showed here on the left hand side, then you can see that this variable stem and leaf plot is being displayed here, and on this occasion you can see the various stems and leaves here as well. So after this stem and leaf plot, let's have a look at the case processing summary, which you can see again on this menu on the left hand side. By clicking on case process summary here, you can see that here on the right hand side we have a detail of the first variable, in which the cases are being written. Now by valid means that how many valid values exist here, and n means the number of cases, the number of respondents, which are total here 720. So valid cases are 100%. All of the values were entered. There were no missing values, because under the column of missing, and if we have a look at the n, there are 0 written, which basically shows that there are 0 missing values. So in total cases we have got n is 720 with 100%. So then again, having a look at the extreme values, again we have a look at the left hand side of the menu. In this case, under case processing summary, we have got descriptives and another part which is termed as extreme values. So by clicking on it, we here are seeing another table which is showing some extreme values which are reported. Now training variable 1, highest case, in this case is reporting, the software is reporting 5 highest values, and also it is reporting the case number which we have assigned, and here case number 6 has reported the highest value of 5. Likewise, highest top 5 has reported in this case. However, if you see under the last 5, there's superscript A written, and below the description is given that only a partial list of cases with the value of 5 are shown in the table of upper extremes. That means that partial list means that there are more than these top 5 cases who have reported these values, but anyhow the software is only reporting the top 5 highest. Likewise, the lowest values here is 1, and in this case the relative cases are also shown here, and again the last in the last row in the last column, there's a superscript B written on 1, and it shows that only a partial list of cases are shown here. There are more cases than here which have got the lowest value, but since the software is only showing the top 5 lowest values, so here we are only going through this. Now coming back to the data view here, for this we have just seen the descriptives and the graphs of one variable. We can have it for more than one variable by going to the same menu, by clicking on Analyze and clicking on the descriptive statistics and clicking on Explore. So here we had already entered the first variable. We can enter any number of variables we like in this same box, and the SPSS would give the descriptive analysis of all of these variables. So by clicking on, let's say, variable 2 on the left hand side box, and again pressing shift key, and we just click on the variable 5. I have selected 4 more variables and all of them are now selected. You can either use shift key to select the first variable, and along with that, while pressing the shift key, if you click on the last variable, the whole range of variables in between the first and last one would be selected. So once they are selected, we can again click on the arrow again against the dependent list. If we click on it, then more variables are selected in this dependent list here. Once they are selected, then we can again look at the statistics spot, which is here against the drop down dependent list. Once we have written, we have already selected all the required information which we require. So we click on continue here, and again by clicking on plots, we have already clicked on the histogram and stem and leaf display. So again we click on continue and we click OK. So here now you can see that a detailed result is generated. On the left hand side, you can see that another log has been created. The detail of the log is given on the screen. Now again, all the variables which we had selected have been analyzed here one by one, and in this case, for let's say we have selected training variable 1, and under this the histogram, the stem and leaf plotting has been displayed. The box plotting will be discussed later, in which we will discuss what is box plotting, and then we will display such kind of analysis in detail. Now going to the second variable, the histogram of that second variable is being displayed here along with the stem and leaf plotting here. Similarly, going to the training variable 3, and the histogram and stem and leaf display is given here as well. And likewise, we can see the fourth variable is histogram, and the fifth variable histogram and stem and leaf display also. So all the details have been given, and a joint case processing summary is given here. We click on this under the log, and we can very much see that the case processing summary gives us all the valid values of all the 5 variables which we have entered, and likewise the summary of missing value and total values are given here as well. So by clicking on the extreme values which are displayed here on the left hand side, the extreme values of all the 5 variables are being jointly displayed in one table. and this becomes a very convenient way when we want to have the descriptive analysis of more than one variable in one table. So here, once we have determined all the relative points which we wanted to explore of all these, so let's go back again to the data values part. Now once we have gone through that, let's have a look at the graph section if you want to draw a graph. And here you can see that there's a chart builder option here. If you click on it, so a chart builder appears, and a dialog box appears that in which it is stated that the measurement level should be set properly for each variable in the chart. So each value label has to be defined. So let's click on OK. But you can define the variable properties before you draw the chart. It's up to you. So we just first click on OK, and here we can see that first of all in the bottom side there are various types of charts which you can choose. One is bar and line area chart, and there are various different kinds of these charts which is displayed in the preview section ahead of that. And likewise there is area chart, then pie chart, then we have also scatter plotting, which we just discussed before. Histogram option is there, and likewise many other options which you can choose for drawing a chart. Let's say we want to go through bar chart, and we have to drag the type of chart we want. Let's say we want to have a simple chart here, which is simple bar. So we click on it and hold the left mouse button on that and drag it to the center window. So once we have done that, then we are asked about that what would be the defining variable in x-axis and y-axis. So we can basically define the x-axis and y-axis properties in the right dialog box, which is written in element properties, which you can see on the right side of this window of chart builder. So let's say I just want to measure the various 5 scales of training variable 1. So I hold the first variable and I drag it to the x-axis. Now once I've done that, you can see that on the y-axis the word count appears, that on the y-axis only the number of respondents who have entered and opted for these various options of training variable 1 would be counted and displayed. So by clicking on OK, we can see that a detailed graph has been displayed here, in which for training variable 1 the number of respondents who have opted for various options are being displayed. Again, this is similar to the histogram, which is showing us the frequency distribution as well in terms of the count, but it's up to you how you use the chart builder here. So once you have gone through that, let's go back to the analyze and selecting, in fact we just click on graphs and select chart builder. So clicking on OK, we can choose different type of charts here which may be required in this case, and it depends upon the nature of data which needs to be presented. So here this was just to show you how to draw a simple graph in SPSS. So let's click on cancel here, and going back to the data values, here we have just discussed how we can analyze the different descriptive features, and more than one descriptive analysis can be attained. Likewise, more than one variable can be analyzed here if it is desired. So once we have gone through all of these descriptive statistics, we will be going through them again because SPSS gives us many options to analyze the data from different perspectives, and as we start learning about other methods, we would have these applications here in SPSS as well, so as to know how to implement such kind of data analysis in a software. So going back to our work here, this was the model which we were discussing, and we basically here studied that how to convert these values mathematically and then how to display them in SPSS. So the one important aspect in this case is related to the numerical descriptive measures, because how to assess the summary of these data which is presented, how to explain this data, how to see that what's the nature of this data which is being presented here. In order to do that, some very basic tools are studied, and here there's a summary definition of a few tools, and first one is termed as central tendency, and central tendency basically tells us to what extent these data values are arranged around a central value. So it gives that, hence the name, it's termed as central tendency. So likewise, the variation aspect gives us the dispersion of the values around the central value, so how much values are scattered around the central value. And then the shape basically is the way how we see these values in a certain pattern from lowest to highest value, what's the distribution, and how we can see these values diagrammatically, graphically. So basically all of these three tools are very important aspect of the numerical descriptives, which are the very first step towards the data analysis. So this is the basics here. Once we have gone through that, then we would go through the advanced feature. The first measure of central tendency is the mean, and we have already known this terminology with another name which is called average. So again, it's the most common measure of central tendency, and in generalized form, if you want to calculate the arithmetic mean, and then it is pronounced as x, which represents the mean and represents by a bar on x, which differentiates the original values with the one which is the mean value, and it's equivalent to the summation sign which is given here, and I here is ranges from 1 to n, and I here is the number of values being considered, and then n here is the total sample size, the total number of values of whom the average or the mean is being calculated. So x1 is the first value here, x2 second, and so on. It goes to n number of values, and we divide it with the total size, the total number of values here which are available to us. So xn is the total observed values here. Going to its example here, again basically this is the sum of values divided by number of values. In short, most common feature of central tendency, and again it is affected by any outlier or extreme value. Let's take an example here that we have got one set of values which range from 11 to 20, and we have just calculated the mean here of the values from 11 to 15. So by putting the values from 11 to 15 and dividing them with 5, because these are the 5 values which we are observing. So in basically the result which we got from here is 65 by 5, which is the mean here of 13 is reported. But as compared to this data set, let's compare this with another data set in which again we are only taking the 5 values, but here we are taking the first 4 and the last value, which is 20. Now here this value is a bit extreme, and we put them in the equation and again divide them with 5, but here we get the reported mean value of 14. Now basically we have used an extreme value which is 20 here, and thus it has affected the mean value here as well. That is why that both the mean values are kind of different, but again not much difference is being reported. That means that only reporting the mean of a certain set of values is not enough, and maybe the mean of these set of values may not be representing the whole central tendency concept. So that is why we need to use other measures as well to assess the central tendency of that whole data set. So going to the second measure, which is also termed as the median. Here it's kind of an ordered array which we have made for the convenience, and here let's have a look at the data set. The median basically is the middle number of the whole data set, that is the 50% above and 50% below. Now here we take the values from 11 to 15, and the middle value here is the 13 here. And as compared to that, let's see another data set which comprises of first 4 values from 11 to 14, and the 5th value is 20. But again here the middle value is 13 here as well, because it is the middle value here. So again there's a big outlier here which is 20, but median here is less sensitive to outlier, as you can see in this example. Then again median may not be much effective in giving us the effective measure of central tendency. So coming to the next one, as a rule of thumb, the median, the location of the median can be calculated from the ordered data through this formula, which is n plus 1 divided by 2. Now by default, if the number of values are odd, then median is the middle number. As you can see in previous example, that there are total values from 11 to 15, and as these are 5 values and 5 is the odd number, so we will take the middle value as median in this case. Then if the number of values are even, then the median is the average of 2 middle numbers. So here n plus 1 divided by 2 basically gives us the position of the median. Again it must be stated here that it is not the value, it does not report the value, but the position of the median here in this case. So we have to be careful in this regard. Again the next one is the mode, the value which occurs most often, and again it's not affected by extreme value, which is its big discrepancy as well, and normally it is used for categorical and nominal data, and again there can be several modes or there can be no mode at all. So in this example here we can see that various values are reported from 1 to 14, and here as the 9 value is most frequently reported, so this is the reported mode here. However, as compared to another example which basically is ranging from 0 to 6, as no value is being reported, so there is no mode here at all. So in this lecture we discussed about how to enter the data in SPSS. More fields were added in the SPSS software, and how different category of variables are added in SPSS. Then we had a descriptive analysis of variables, how to get the histogram, frequency distribution, stem and leaf display, and the case processing summary along with extreme values in SPSS, how these are reported, because that is beneficial for us to have a detailed analytical basic review first for all variables. We can have them for single variable and for multiple variables as well. Then we had a view of how to draw the basic chart in Chart Builder facility in SPSS, and then we had a brief overview of what are the numerical descriptive measures, which are the basics of any data analysis. And in this case the first foundation is the central tendency part, and we had a brief overview of what's meant by mean, what is meant by median and mode, and to what extent these terms can explain the data dispersion and how much effective they are and how much affected they are through outliers. So if we want to basically explain these central tendency measures in more detail, just for the sake of our clarification, this is pretty much obvious that mean basically represents the average of the values which are there, and basically this average or mean construct is one of the very basics. That's why it is calculated at the start of every analysis step, whether you are dealing with the software or whether you are trying to manually check the characteristics of a specific data set. That is the very first step to do. So average is very much important. Likewise, in median we are dealing with the middle value, and as we are dealing with the middle value, and in this case if the number of values or number of total data values are even, then the process of selecting the median or calculating the median is different. In case the number of values, total values, are odd, then obviously we are selecting the middle value of mean. Middle value of all these values. So median basically is taken as the average of in between two values if the total number of data values are even, and in that case then also regarding mode, we basically are dealing with the values which are occurring the most in a data set. All three values basically are reported in every kind of analysis, in whether we are applying a sophisticated analysis like regression, and whether we are applying a simple descriptive measure, and for any kind of data, the mean, median and mode are normally the first statistics which are reported, and obviously they are also first observed. So that makes the central tendency measure very important, though there are many other more important measures as well, which will help us in clearly identifying different characteristics of the data set, rather more clearly identifying the characteristics as compared to these. But this does not diminish the importance of mean, mode and median, because despite the fact that, as we have just demonstrated in this lecture, that all three central tendency measures simply relying on any one of them will not give us the true picture of the data, but still all three have got their importance in their own perspective, and that's why their value is still remains important. Even when we are having the results regarding regression or sophisticated techniques, those values are also compared with the mean value or median value of individual variables, just to have an idea of how much representative or sophisticated analytical tool is of the data set which we are trying to test. So this would be foolishness to undervalue these simple measures, which sometimes give us some very vital information regarding the data sets. So basically all these techniques of descriptive analysis and these central tendencies are way of explaining the ways in which the data can be represented more effectively, and the more different ways are used to display the data, to present the data, the more chances are that we will end up in getting more vital information about other dimensions of the data, which at the first instant we may not have been able to find out. So that's why the descriptive analysis, which you may have studied in your previous grades as well, but their importance still remains the same, and that's why these analytical measures are reported in every report at the start, because these statistics, no matter how simple, sometimes, and in fact most of the times, give us very vital information, and the importance of such cases cannot be ignored. So I hope you have understood this lecture. Thank you so much. Allah Hafiz.